Over 2,000 years ago, a Greek philosopher constructed a logical argument proving that motion itself is impossible. It sounds absurd. Obviously things move. But nobody could find the flaw in his reasoning for centuries. Let's walk through exactly why. Picture a race between Achilles, a legendary fast runner, and a tortoise. Since the tortoise is so much slower, it's given a head start. A philosopher named Zeno of Elea argued that, using pure logic, Achilles could never actually catch up to the tortoise. Not that it would take a long time, but that it was genuinely, mathematically impossible. Zeno actually constructed several of these paradoxes, all designed around the same central goal: to prove that motion, as we normally understand and experience it, is genuinely logically incoherent. For Achilles to catch the tortoise, he must first reach the point where the tortoise currently is. But by the time Achilles arrives at that exact spot, the tortoise, which has also been moving the entire time, has advanced to a new point slightly further ahead. So Achilles must once again close this new, smaller gap, and once again, by the time he arrives, the tortoise has moved on just slightly further, creating yet another new gap. This repeats, according to Zeno, infinitely. Zeno's conclusion followed logically, since there are infinitely many of these ever-shrinking gaps to close, and each individual gap takes some non-zero amount of time to cross. Achilles can logically never finish the infinite sequence, and therefore never actually catches up. This obviously contradicts what we observe in reality. We know perfectly well that a faster runner easily overtakes a slower one, all the time. So where exactly is the flaw hiding in this argument? Zeno had another version of this same argument, applied to any single act of movement at all. To walk from here to there, you must first travel half the distance. But before reaching that halfway point, you must first travel half of that remaining distance. And before that, half of that, this subdivides infinitely, all the way down. This means, following Zeno's logic, you could never even begin moving in the first place. There's always some smaller first step required before any motion could ever start. Zeno's core mistake was assuming that adding together infinitely many individual numbers must always produce an infinitely large total. That assumption feels intuitive, but it's actually false. An infinite number of terms can, in fact, add up to a perfectly finite total, as long as each individual term shrinks fast enough as you go along. This idea, known today as a converging infinite series, simply wasn't rigorously understood or proven during Zeno's time. It would take mathematicians many centuries to properly work out the details. Let's go back to the dichotomy version and actually add up every single distance Zeno described. 1/2 of the total distance, plus 1/4 of the total distance, plus 1/8, plus 1/16, and so on, forever. Each piece exactly half the size of the one before it. Add this infinite sequence together. 1/2, plus 1/4, plus 1/8. And so on forever. And it converges to exactly 1, the whole original distance. Notice the pattern here. Each new piece fills in exactly the remaining gap left over, getting smaller and smaller each time, but mathematically never quite reaching 0. And yet the total still lands precisely on 1. Here's the key piece Zeno's argument overlooked. Each of these infinitely many steps also takes a correspondingly infinitely shrinking amount of time to complete, not some fixed chunk of time, as the original paradox quietly assumed. An infinite number of individual steps, each with a proportionally shrinking duration, still adds up to a completely ordinary, finite amount of total time, exactly the same way the distances did. This precise mathematical idea, that infinite sums can converge to finite values, would later become the foundational core of calculus, developed roughly 2,000 years after Zeno first posed his paradox. Zeno wasn't actually wrong that these infinite subdivisions genuinely exist. Mathematically speaking, he was wrong to assume that infinity must always translate into an infinite total. Sometimes, infinity converges. It took over 2,000 years, and the eventual invention of calculus, to finally explain with full mathematical rigor exactly why Achilles really does catch the tortoise, just as we always knew he would. Sometimes the strangest, most paradoxical seeming ideas in mathematics aren't actually wrong at all. They're simply ahead of the tools that eventually get developed to properly explain them. Thanks for watching. Subscribe for more science visualized.